Hi, this is the Liquefaction Hazard App built by Tyler and Kevin.
We built it for the Civil Engineering 514 class at BYU taught by Dr. Ames.
So the purpose of this app is to help with geotechnical engineers find hazardous locations for liquefaction.
Yeah, coming up pretty shortly, Utah, including many other states, will enact a law that requires developers to use certain liquefaction data and compute different liquefaction formulas to implement in their designs to make sure that they can withstand certain liquefaction circumstances. We built this app for the class, Civil Engineering 514, and also for Dr. Frankie. One of his master's students and him have been collecting a lot of different types of data that needed to be served to different developers so that they could plug it into an Excel file that has a bunch of different like VBA code and formulas that they can use in the design of their projects. And so our app basically provides that data, and it will be shown here shortly. The reason that they wanted to provide this data online is because they're going to be handing out this Excel document to all developers that need to use these data according to the law. But they have probably about 20,000 or more data points per state. And that's a lot of data points in one Excel sheet to be giving out to tons of people. So we've basically cut down, by providing this data online, we've cut down this Excel file from a couple gigabytes to a couple megabytes, which is really useful for if this is going to be used in the law across the whole United States in the future.
So the data that was stored in the Excel files, we had to first take them out, and then using ArcMap, we turned them into shape files as seen here. And then we created a raster and then finally exported it as a TIF file that could be loaded up into GeoServer. The map, the raster was interpolated using a kriging function.
As we were developing this app, we were trying different ways to serve this data, whether that was put the Excel documents on our server directly, but we found that the easiest way, like Kevin said, was to use ArcMap and to conduct some kriging on those files, and then put them on our GeoServer. And this produced a very, very quick and dynamic app online, as you'll see shortly.
They wanted us to use this kind of diagram to help find the interpolation, where we find one point or one data value from each of the quadrants as shown, and then find the closest one to the point as shown with the as the origin of the x and y axis, and use an IDW interpolation for that. But as shown in the next slide, we actually decide to use something different.
Yeah, so the middle of this diagram would be the coordinates that the user inputs in the website, and so we use kriging. This is an example of one of the kriging TIFF rasters that we created using the Excel files in ArcMap, and this file is what we pushed onto our GeoServer, which will be used to extract the values at each point in our web app and displayed for the users to input into the Excel file with all the formulas that Dr. Frankie's master's student Braden will include it in the Excel file.
Here's a demonstration of our app, and when you first open it up, you come to the home page where you can find a little more information about that. To our left is a button of documentation, but we'll be later on adding more documents to it.
So we'll go to the map now. Here we pull up an OpenLayers map of the whole world. Currently, our app only has data for Utah, as shown by the cursor around this cursor on the map. So the user will come in and they will first select their state, and like I said, we only have Utah, so we'll leave that selected. And the data, there are 7 values that our app needs to pull, and each data point has a model year and a return period specified. And so we'll leave these here, and we'll submit to populate the query fields. We'll zoom in here on Utah, and the users will be able to either click on a point. Here's Utah. You can see Salt Lake right there, or they'll be able to type in a Latin long. So we'll pick a point here near the lake and see what happens. So as we can see, we have this little pop-up box. First, it shows the exact coordinates where you clicked, and here are the 7 values that the user needs to pull and enter into the Excel document with all the formulas and things that they'll be using in their design that Braden, the student of Dr. Frankie, will provide.
Further improvements that can be made on this app, as Tyler's talking about, we'll be adding in more different rasters of each different state. And then currently they're working on the 2014 model year for each of the states. And then other improvements could be just making it more user-friendly.
Yeah, we can also experiment with different open layer maps. Maybe we could do a street map, whichever one would, or maybe have multiple. The user can select which one they want to look at. Yeah, we will continue to work on this app even after the class project is over and continue making improvements. So now let's take a look at the code. So a lot of this has to do with the Tethys environment. If you're not familiar with it, I would recommend that you go to the tethysplatform.org Google Tethys platform and read some of the documentation, because we'll be mentioning a lot of that here. So we're mainly going to talk about the meat of our project, this map page. This is the controller for our map document. Tethys provides gizmos that just kind of make it a lot easier and quicker and prettier, consistent styling sort of to pull different values in. And so here we have all these different, they're all either select inputs or text input gizmos. And this is for our states, where they can go in and select the states, as you saw from our map. Right now we only have these various states that you see here. We can easily add more more states as we collect data for other states, and other states start enacting these laws that require contractors to use this liquefaction data. Here with the text input for the latitude, for the longitude, the model year, and the return period. And as you can see, these model years, about every 5 years they redo this data. We'll see if it won't be hard to continue making improvements on this app as they add more data. Here are the return periods, and basically here is we're pulling this data from these gizmos. If the user inputted them, then they're pulling them into these variables, passing these variables back into the HTML through this variable called context. And we'll see that here in a second when we go to the map HTML. So we load the gizmos right here, and we pull in, here's where we see those gizmos laid out on our page. So we have this form that you see right here. Here's our form, and here are all these gizmos. Yes, we have a submit button, and these values get populated as the submit button is pushed. And now Kevin will talk about the map itself.
So first off, we created a container for content enclosure, which is all for the pop-up, and these reference properties in the CSS file. So we first make an overlay functions to anchor the pop-up, and then we have a here we create we create the map itself. Later on, we then create the actual pop-up with the on-click file. So here we're having the closer function, which as seen here, which creates the X, so we can actually close the pop-up itself. And then the on-click function will actually be further down, because we're actually pulling data from the GeoServer and actually inputting it into the pop-up itself, created here with the single click function.
Yeah. So this context, it's a div. This is basically the div for the pop-up, and we're populating it down here as we pull this data from GeoServer, and I'll kind of explain how that works. So basically, the first thing that gets populated on our pop-up is this location with the coordinates that we have here stored in this HDMS variable. So open layers, what we do is working with GeoServer, we make these a new tile layer of open layers, and right here we dynamically call the different files of the rasters, the TIFF files that we have stored on the GeoServer, and it gets populated with the return period and state and the model year that the user inputs in our form on map.html. One really interesting thing that we worked pretty hard to kind of debug and work through is getting these, basically passing these variables that we used, these Django variables, back into our separate JS file, this map.js. What we found after some research is we can just create these global variables in a different script right below the call to our connecting our map.js file. And then in our map.js file, we can just call those global variables without even defining them here in this file. So basically, these files they're all labeled the same. The only differences are these model years, and so the convention is the same. We dynamically pull those. So whenever we add new states or new model years or different return periods, our program is dynamic enough to handle that, which is pretty exciting. So it creates this new layer, and we have 7 of them, so that you'll see 7 of them labeled based on the data that we're trying to pull, the CSR, the CEEn, or the INY. And we come down here to the on-click event, the map.onClick event, which basically pulls in the coordinates that we use here as well. So we are getting the source of these layers, these tiled layers, passing the source into this get feature info URL, storing it into a URL here, using the on-click event coordinates on the map, the resolution, and this get projection, because the projection may change. Once we have that URL stored, basically if we opened one of those URLs, it would take us to a page with some JSON data. Yep, and so the URL gets passed into this get JSON data. We parse through the JSON to get this gray index, and that's the value for each of the data endpoints, and it appends it to the div right here. It makes a new paragraph, and it populates it like so. It's fast and it's awesome, and we're excited to continue to improve this project. Thanks for taking the time to watch this. Hope you enjoyed.